you still need a lot of people that do understand the code that is generated by a bot. And you still need a lot of people that are able to coordinate the generation of the code in a way that produces systems of code. Because that is usually not just a snippet of code that kind of solves the problem, um, in a way that is functional. And so all those things just to say that I think we're not yet at a point where we can kind of call that the work of software engineer not useful anymore. But definitely we're going in that direction. I have no problem saying that.
Hi, everyone. Thank you for joining episode 8 of the polling principle. I'm very, very excited about this one today. I'm here with Massimo Mascaro, Massi, who is a former colleague of mine back when I was at Google, and he's an expert on AI. And I think we'll have a really interesting conversation. So thank you so much for joining me, Massi.
Oh, great to be here. Thanks a lot for having me.
Cool. So to begin with, maybe we'll talk a little bit about what's your background, what brought you into AI, because originally you come from the world of physics, right?
Hello.
And so let's tell us a little bit about what was the path that took you to AI and then to Google and then the office of CTO at Google and what a little bit about the kinds of things that you do in your day to day today.
Yeah, absolutely. And as many people that are today in AI that are kind of a bit more senior, of course, I didn't have a very linear path. So as you said, actually, I started in physics, particular quantum field theory, and I was having the time of my life doing that. Um, until I basically decided to follow this course on neural networks, and this was like in the 90s. And there is this kind of very important connection when we can actually kind of talk more about that later, but between very large, complex systems of particles, uh, and in particular, kind of their phase transitions in certain conditions, and the way in which associative memories in neural network work. And so, I got really interested in that topic, and I started working on that from a research perspective. And then that led me to do a number of things. So while working on that, I started working also on computer vision, mostly initially because I was interested in finding good use cases where to apply those theories. But I got really, really interested in the problem of character recognition, and particularly using some of these novel network techniques in that context. And particularly, this was very, very early time, but the theory of attention. And that also got me to be very, very interested in the actual kind of biological brain. And so I decided that I wanted to kind of get much deeper, and decided that my PhD was going to be in computational neuroscience. And so that's what I did. And I studied a lot, like, again, the visual cortex, particularly in primates, a lot of like work around the mechanism of attention and the mechanism of coordination between different sensory systems. Um, and then eventually I started working more on application. And so I built actually a number of systems for OCRs, applying, again, some of this inspired theories. And that led me to work for kind of more tech companies. So I worked at Microsoft, I worked various startups, and then Intuit, where I basically started the data science team there and became the head of AI. And then finally kind of I landed at Google, where I've been in the office of the CTO, where I met you. Um, for the last 7 years and a half.
Awesome. One interesting thing that came up as you were saying that is the way that scientists and engineers look at AI or I guess other technologies in general, right? And how from the science perspective, the interest questions are, like how does the human brain work, right? Like, what can we learn about it? How can we, kind of influence, the way it works or whatever. And I guess from the engineering side, what matters is, can I build a tool that does a specific function? And that, you took inspiration on the brain, for that, right? And that's where, neural networks originally come from, right? But I think, right now, it sounds like not so many people actually care so much about, the inspiration of it, right? It's all about, what kind of problems you can solve with AI models, and that's it, right? I don't know. I guess the engineering mindset, completely overtook the world of AI.
Yeah, I mean, I agree with that to a large extent. I think there's still a pretty vibrant community in terms of, for example, computational neuroscience, of people that really kind of are the one kind of trying to open in the can of how the brain does it, right? But it is true that the more some of the discoveries of the last 30 years started become practically applicable, the more this became a very, very strong engineering problem. And people kind of started focusing a lot on applications. Now, I mean, I personally have, of course, like a very keen interest in also understanding the connection of the two things. And I think actually there are a lot of like reasons why you want to still look at the, if you want, kind of old, billion years evolved kind of, neural systems in mammals, because effectively we still know that our neural system is vastly more efficient than what we have built so far. And there are a number of like characteristics that we still haven't been able to emulate completely in some of those artificial systems. That said, I mean, of course, as things started working, when I started working on this in the 90s, it was a little bit of like almost considered a dead end. We were coming out of like a second AI winter. Applications were really scarce and very often like not very competitive with like kind of more kind of computational approaches, especially in the area that I was working on, like computer vision. Um, so, like, in a sense, we've moved from one excess that is, don't look at that because it doesn't work, to another excess that is, yes, it works, so don't care about where it come from. And I think actually, of course, with anything, actually, kind of very often the optimal is in the middle, and I think actually there's still a lot to learn actually from the biological systems.
Okay, so you touched on a lot of really interesting things. So, what does it mean that the human brain or biological brains are more efficient than computer brains? Is in terms of like power, power usage, or energy, or like in what sense are they more efficient?
Yeah, there are various senses. So one is definitely power. There is this kind of statistics. I personally kind of don't know exactly how they get those estimates, but like kind of normally we think actually that our brain runs on a few watts of power normally when we're awake, and much less, of course, when we're not. Uh, and this actually kind of compares with literally kind of kilowatt of power for just inference in modern kind of large language model, for example. Um, and and that actually is a stark difference, orders of magnitude. The the biological part also kind of comes with a very, very different substrate. So our neurons are able to, in a sense, we're still competing with a lot of like the large models, I would actually argue. Um, but if you look at the components, and not only they use much less power, they're also much slower. Typical neuron response time, you're talking about tens of milliseconds. Versus if you compare it with like modern electronics, you're now kind of in the nanosecond range. And so like there is also like way, way more exchanges, if you want, that go into, let's say, one output generation from a large language model than from me outputting kind of words right now. And so that's also another gap. There are also kind of a lot of gaps that you can identify in learning. Um, we we're intrinsically a online learning system. We learn as we go. If you were to tell me something right now in terms of feedback, I will immediately kind of take it as mine and kind of immediately learn from it. In most cases, while typically kind of systems in artificial networks are trained in batch modes, like you have like a very distinct phase of training versus inference,
Hmm.
and and actually they are also kind of trained in a very, very different way because usually they optimize a global function. As far as I'm aware, like this is not the case for biological systems. So
Yep.
and I'm just kind of skimming through a number of differences. Of course, there is the fact that we're embodied and we intrinsically kind of have to deal with a lot of modalities at the same time if we just want to survive. There are many, many differences. And I think actually all those things are interesting for a number of applications if you just kind of are interested in applications. So that's why I think that some level of investment in the study of biological systems is still absolutely kind of valuable. Um, of course, I'm also very happy that systems have started kind of having success in applications per se. And this, of course, kind of is very beneficial for the field as a whole. So, like, I'm not discounting that. I'm just saying that it shouldn't be the only thing.
Yeah, I mean, I think like and lots of interesting, topics that we could do a little bit deeper, right? But one thing that you mentioned was areas where maybe biological systems are more powerful. Like for example, multimodality, right? In a native way, but is harder to do with, I guess, language models or transformer based, type of model. Um, I wonder, if I was somebody that is just trying to understand what is happening in the world of AI without having any kind of background, I think the question that would come up is, well, when are these systems going to reach a level of intelligence or a level of functionality where they can, replace, a large number of, human tasks, for example, right? I think, maybe some of the things that you mentioned about being able to learn without having to be retrained. Um, about understanding multiple modalities, in a native way. When somebody is speaking, when somebody, shows an image, be able to understand the video and so on and so forth. Like those are, important things, right? Like, what else, do you think would be important for that? Like, in some ways, what else are, large language models missing, right? Before they reach a level where you can say, okay, yeah, these things are really intelligent, right? In a human sense.
Yeah, it's a tough question because we as as scientists and even as a society, we haven't really kind of really nailed a definition of what we mean by intelligence, right? And of course, actually, kind of that definition will be crucial to completely answer your question. Um, and actually, like if I can actually open a parenthesis here, um, until I would say until 4 or 5 years ago, there was no question that we were more intelligent than any machine we had ever built. Um, Now the thing is a little bit more gray, although I would still be in the camp that we're still kind of beating most system that we've built. But things are changing very rapidly. But one thing that is definitely true so far is that all the natural intelligence, all the intelligence from the, if you want, the natural world, and includes humans, um, comes attached with consciousness. Um, all intelligent beings that we know of, at least that I know of, actually are intuitively conscious when they come from natural world. Where all the artificial form of intelligence we have created so far, I think most people would kind of not be too debating around the fact that they're not conscious. And so, this idea of building intelligence with consciousness is a little bit of like an extra concept that we don't really have a lot of intuition for. And I think actually this skews a lot of things. And so I'm just kind of making this big parenthesis in that I believe there are some systems that have which very, very high level of intelligence if you look at that intelligence per se. Things about, I mean, if you think about the work that we've done at DeepMind around proving mathematical theorems, but even like the ability to very, very quickly do inferences between different concepts and images that kind of modern LLMs actually are able to do, I think it's pretty striking. And I think, again, I don't have a very good definition of intelligence, but I think actually kind of it really compares with a lot of ways in which we normally kind of in normal speaking, actually, we would characterize intelligence. We would actually run, for example, an intelligence test on some of these LLMs, and they usually perform pretty well. They perform pretty well on things like the SAT test and like law school tests. So knowledge tests, absolutely, but also like they're getting better and better at inference, deductions, analogies, and even creative stuff to a lot of extents.
I thought somebody ran like basic IQ tests or like, standardized IQ tests for some of these language models. And some of them were scoring. And, I think we saw it over the past like 2, 3 years. Like they started to score in the 70s and 80s and hundreds, right? Because they would fail a lot of obvious questions that humans wouldn't. And I think the latest, like GPT 4.5 or Gemini 2 or, or Claude 3.5 or whatever, right? Like this was maybe a few months ago. A lot of them started scoring in the 120s, 130s. That is a smart human being, right?
Okay. And like the other thing that I don't know if people are really taking into factor here is that um, it's not just kind of the raw score, is that now you can, clone that. Like if I have an individual who is really smart, as an individual, I mean, I have no guarantee that any of his descendants actually wouldn't be that smart. Versus actually these models, you can basically kind of clone them and you can usually kind of make like advanced versions of them with relatively little effort and make them even smarter or maybe at least as smart. So, that's actually the replicability of that intelligence is extremely powerful. As I always say, like, I mean, another example of this is like, I think autonomous cars, if you think about what Waymo is doing, kind of driving around cities, it's a form of intelligence. I mean, it's understanding the world, is taking decisions, is making kind of, choices about where to go and when to stop and how to stop. Um, and that you could actually argue, well, I mean, they're not better than good human drivers, and I could actually give you that. But even if that's the case, the fact that you can take that intelligence and that if you want kind of good driver and now clone it into as many cars as you want. And all of those cars actually will be equivalently as safe as that initial car that you prototype. I mean, that's actually huge. And that is something, again, like similar to consciousness. It's something that we're not used to think when we value a certain level of intelligence. And actually it's definitely true for these artificial systems.
Um, yeah, and I think maybe we'll leave that a little bit aside for now. And I think maybe it's a good thing that these models don't have consciousness or agency, right? Because we have a very, very poor understanding of what fully agentic and conscious AI system would do, would want to do, or, how they would feel about the world or whatever, right? Like, maybe, I don't know, maybe it's a good thing that these models are just intelligent and they perform tasks for us as opposed to wanting to do things on their own, right? Like every other, entity in nature, that's right.
I completely agree. And I think, in fact, I mean, as I said, it's a new concept for us, but like there are tons of applications where you want intelligence and you don't necessarily want consciousness, right? I mean, the autonomous car I said before, to use actually, this is an example that comes from Yuval Harari, the historian.
Mhm.
Actually was talking about exactly this thing. And says, when you go into an Uber, you get a driver. He may be a great driver, but like you have no idea what is going into his mind. And like, maybe these squawk will that make what I'm saying is that that is not necessarily desirable in that maybe that guy just had like, I don't know, very bad news that morning or like had a fight with his wife. And like, in a sense, you know that that is going to affect his driving and you don't necessarily want that. Like a Waymo car is in a sense is much more, uh, kind of simple from that perspective. But actually that's what you want if you just want a car to drive you from point A to point B.
Yep. I think one way that I mean myself and I think others have been talking about it is with this little shift into agents. Like, sorry for introducing it maybe in a little bit of a brusque way, right? But in a lot of maybe AI before the past few years, we would talk about AI systems or AI algorithms, and then talk about AI models, right? And then the models perform one or a series of functions, right? And now, lots of folks are talking about AI agents, right? Which, in some ways are, basically models that have a little bit of infrastructure around them to maybe give them a little bit of a sense of, not necessarily agency, but a little bit of a purpose, right? An ability to perform more complex functions than what an individual model would do, right? Um, so agents are not new, right? Like people have been using agents in AI for a long time. So, maybe let's start with that, right? Like, how are agents today different than agents, 20 years ago, right? And what are the kinds of things that we can do now, for example, that we couldn't do before?
Yeah. I mean, as with all these words that have like a lot of like overlaid meanings and things, it's very often important to kind of, characterize what actually you're talking about. This again, agent is such an old and, rich word and be used in many contexts from philosophy to, kind of artificial intelligence in many, many ways. Um, so, I mean, if you want, we can go a little bit through some of the history of this, but like it just kind of, in a sense, I think it's important to recognize that when we talk about agents, we're talking about entities that are able to perform some actions. And, this is actually also how kind of those things have been typically kind of taught into both, philosophical literature, but also like more recently, like, for example, if you look at way before large language models in the reinforcement learning literature, there's one of the techniques you use for training things. Actually, agent was the big word that everyone were using. And typically, those are systems that characterize entities that perform actions in some kind of environment. This, by the way, could doesn't have to be an action in the real world. It could be like a completely artificial action, but it's still an action. And typically, the agent characteristic is that the action is performed in a situation where there are multiple choices. So, in a sense, that action is not just like, okay, I have a system that is able to send an email, right? It's also that there is a choice between doing one or more actions, and that actually that typically how agents. I mean, this at least is the root of the agent, if you want, kind of in that context. Now, when you apply them to large language models, some of this characterization is maintained, but also there is much more of an emphasis on the interaction between different of these entities and interaction between those entities and humans. And so, in a sense, it's almost like by extension, one of those actions would be to communicate or to invoke something else. And that something else may be another agent, another, if you want, artificial intelligent agent, or it could be also like a human, where kind of you have now artificial intelligence maybe kind of summoning a human to do a particular thing or to help with a particular thing. And so, in a sense, a lot of the emphasis today, it is still on this kind of action and choice of actions, but it's also on the how do you get effectively AIs to collaborate together in performing a higher task. And this actually is very exciting because, in a sense, it's unlocking a number of things that we were honestly having difficulties doing in the context of a single AI trying to kind of solve the entire problem.
Mhm. But it seems also like that has been a little bit of a step change in the sense of the capabilities of this type of systems, right? Like, if you have if you had an agent, no matter how smart you could build it 10 years ago and said, well, this agent is going to perform functions similar to a human in their day-to-day job, look at information, analyze that information, make decisions, communicate that with other people, you would not have been able to build anything that would resemble a human being, right? Like there were so many technologies that were just not ready. Now you can have these agents that understand images, understand how to interact with, computer systems. In that way, they can process data, of course. They can um, create audio, voices that resemble actual human beings. You can have an agent that calls somebody, right, and then notifies them
Mhm.
or something, right? You can, in some ways, we're also maybe reaching the point where, a lot of the, understanding of, how to create robots and so on and so forth is becoming much, much better, right? So, like, I think there is a line of sight towards, agents or multi-agent systems that perform functions that are very similar to what a human does in their day to day, right? Which I think, in my mind, is not just a slight increase over what we had before, but it's a substantial step change in the sense that once you get to a point where these things can perform the job that a human does, like it has drastic implications, in terms of society and economics and so on and so forth, right?
Yeah, no, I agree. And, I think definitely we are in a period right now that is exciting in that, we see this transformation happening, under our eyes. As you said, like 4 years ago, the most advanced model was not even remotely passing what we call the Turing test. That is, it's a very famous test from the post-war area where the idea was you have built something intelligence when, talking to that something, you would not realize it's not a human unless kind of somebody tells you. And I believe that, a lot of like the modern LLMs actually pass that test,
Hmm.
at least to a large extent. And that almost kind of passed by without, too much fanfare if you think about it. And now actually I think, to also be fair, we have changed the bar and we're now kind of recognizing that the Turing test per se is not necessarily kind of intelligence. But, like 4 years ago, we didn't really have, maybe 5 years ago, we didn't really have something that we could actually kind of pretty easily say, oh yeah, that would pass the Turing test. So amazing evolution and speed of evolution. The and so this comes with what you just said. That is, we start having some of the systems now being able to perform at least limited task, and a performance that becomes comparable to a human. And there are a lot of implications in this. I would call out a couple of things though, in terms of like kind of structuring that, because I think actually that's a very important discussion to have. But I think it's important to kind of structure, layer on top of that two more things. One thing is just kind of the historical aspect of we've been, hundreds of years in the making of automating a lot of things that humans do, right? So, like, in a sense, this is somewhat not new in that we have been doing this for many, many things. Now, it started with, more kind of labor and kind of physical things that we would do, but actually has evolved actually over the last few decades in a lot of like mental and, if you want, intellectual things that we endeavor as humans. Of course, this is the next level. Don't get me wrong. There is a very, very distinct transformation. So that's one thing. The second thing is what we were calling out before. That is, it's always important to keep in mind that all the systems that we're building, whether they may or may not have intelligence, and again, it depends on how you define it, they definitely do not have consciousness. And so you have to take that into account because there are certain parts of human endeavors where you may want to do a task. Just like I made the example of the car before, where maybe I don't want consciousness in that thing. There are other things where I absolutely want consciousness. Um, there are ethical aspects. Sorry, what?
Such as what? In which cases would you actually want the system to be somehow, conscious, right? Like, what would it be able to do that it cannot do, without it?
Yeah. Well, more than able to do they wouldn't be able to do is like what kind of guarantees can you attach to that kind of doing. So I think actually a lot of the cases where you see today kind of people still demanding some level of consciousness in whoever actually kind of makes decisions are things actually of course that kind of characterize various levels of ethical endeavors that or ethically rich endeavors in our activities. So whether it's kind of politics and law or healthcare or defense, there are a lot of, in a sense, aspects where a lot of folks actually still actually are not at a level where they would trust non-conscious entities to be completely in charge. Versus, I mean, again, I'm separating this versus other endeavors where maybe you may feel more comfortable. If I have to, I don't know, automate a drone to go explore Mars, I don't necessarily care that the thing is conscious. In fact, I want it to be as intelligent as possible, but kind of probably I don't want it conscious. But like if I want actually a doctor to kind of give me a diagnosis on something bad that may have happened to me, a lot of people still value that consciousness and that empathy that actually still not present in these systems. And again, and we don't even know how to define it. We don't even know where it comes from. So like we're pretty far from reaching it at the moment. So I'm just kind of layering these two aspects because what they say is totally true. We are kind of seeing, if you want, an expansion of the area where those systems are able to, if you want, kind of either match us or at least kind of augment us to a large extent. Uh, but at the same time, I also warn that there are aspects that those systems still do not have, where a complete, if you want, kind of substitutions of human beings is absolutely not advisable, and probably like a lot of people wouldn't want it.
Yeah. Let me argue a little bit against that, actually. So there were a couple of couple of points. One of them is just I think it was 6 months ago, maybe a little bit longer. DeepMind came up with this system. It's called Amy, right? That does automated medical diagnosis and it interacts with patients via chat system. I think one of the interesting analysis that the team did is they compared the uh, empathy of that system versus a human doctor. Uh, and they did that by putting the system and putting doctors talking with patients that had received a diagnosis, and then the system Amy got better scores than the human doctors, right? So the fact that the system has no consciousness, right, doesn't necessarily mean that it cannot project empathy in a way that is felt by the human patients, at a higher way, right? So I would argue, I'm not sure, on the medical area, it's necessarily a good idea, right? Or at least we don't really understand that yet, right? I would say the second one is, maybe part of the issue is that we as humans feel that we need to understand how the system works in order to trust it, right? I was just talking with somebody else in drug discovery, right? And how sometimes in drug discovery you feel like you need to understand how a specific molecule works, but at the end of the day, the only thing that matters is does it work or not? Does it cure the disease or not? And can you prove in a in a proper way, right? With a statistical sample with the right power and so on and so forth, using the right experiments, can you prove that it works? And if it works, it doesn't really matter. It shouldn't matter, whether it does it in one way or another, right? Like if you have a molecule, a magic molecule that could cure, cancer X or Y or Z, right? Like that's really matter that you don't understand the mechanism of action or not, right? So I would say, you know, what you're saying is maybe a fact or an effect of the fact that we humans feel the need to understand, but I think we will probably overcome that and we'll get to a point where just we don't really know how these things work. We don't know if they are conscious or not, but as long as they perform an economically useful function, maybe we'll just be fine with it, right?
I think you're raising a great point, and I partly agree with you in that And there is definitely an aspect here of like societal, if you want, adaptation to some of these technologies. I don't know if there is this kind of famous stories about when they invented the first cars. There were people that would just kind of refuse to take them uh, because there were these mechanical things that would just kind of go with things like they were least.
To have a person walking in front of the car, right?
Exactly, exactly. So, I think actually this may be another example of like maybe kind of, 50 years from now will be completely normal to have a doctor that is an AI, and like no one will really kind of, care. Uh, but I think there is an aspect a little bit more than that. And actually kind of to give you another example, like and that, by the way, this is definitely personal. I'm not trying to kind of try to kind of make like a generalization. This is going to be, I mean, I think different people will have different preferences. But for example, today there are people that would not actually talk with a customer support agent in voice, no matter what, and they just prefer any form of like messaging or email. But there are other folks actually instead actually they just
Right, a lot of those agents, they cannot issue refunds, which is what you want. But it's like eventually what you want is someone to give you a refund, right? And the agent is not authorized to do that.
yeah. Yeah, that's the trick part. But one thing is that there are also people that instead they want to have that interpersonal relationship. And so again, um, for example, like I think in the DeepMind studies that you cited, if I remember correctly, the patients actually did not know whether the doctor was an AI or not.
Yeah.
I don't know actually how much it would change the study knowing that that AI. I remember like I don't know if you remember like a few years ago when Google launched this system, Google Duplex, that would actually call restaurants and different services to make reservations on behalf of other users. And it was a bot. There were some people that really kind of, in a sense, kind of had an issue with that because the system was not explicitly saying that it was human, and some people actually kind of thought they were talking with a human, they were talking with a bot. But I think actually we'll have to go through a number of like I think societal adjustments here, and I'm not sure where we'll land because like in all those things, it may be actually just a preference thing. It may be also like some societal norms will kind of arise where certain things will be acceptable, certain other less acceptable. But definitely, it's an evolution thing, and my point is just that things are moving very fast right now, and what this kind of transformation, think about the car, right? Our transformation used to take like decades to really permeate in a society. And now instead, actually, these are happening in a matter of like years. And so like we have to be in a sense much more agile as a society to absorb some of this stuff. And there may be like a number of issues because maybe we're not agile enough in absorbing some of this.
Yeah. I think one interesting uh, stat or chart that I was looking at recently was the number of software engineering job position open over the past 4 or 5 years, right? And how it was kind of slowly growing, and then it had this huge spike during COVID, and then it went up. It went down drastically, right? And now it's like same as it was like 4 years ago. And a lot of people are saying, well, that may be because language models and agents using language models are very good programming, right?
Mhm.
In some ways, right? Like, they can write a lot of code, in many cases they write it properly or whatnot. So I wonder if, maybe one of the first economic implications of having these agents be very good is we will have less jobs of software engineers, right? Or we'll have a lot more software development with the same number of people, right? Either way, right? Like, it comes down to like, this was maybe uh, an area where there were lots of openings for humans, and maybe part of that work will be done by agents, right? And I think it's in some ways ironic, right? Like that software engineering would be one of the first things that may be partially automated by some of these agents, right? Like even how inherently complex it is, right? But I don't know. I mean, I wonder, what do you think about that? Like, do you think this is an area where we kind of, co-evolve over time, right? Or like we will see, society actually having to change, right? So that people perform other tasks, right? Because now we have this, amazing tools.
Yeah, so I think actually we don't have the answers to that, at least precisely. I'm personally a bit skeptical that the big drop in software engineering position is mostly attributable to AI at the moment. I think actually that has much more to do with both economic cycle and efficiency that a lot of like the tech industry has been, seeking. I would actually argue that, over the last 3, 4 decades of software engineering, we went through like a huge improvement of the tools that we use to produce code. And so like, if that's the only reason, then I would say, modern compilers should have slashed actually the amount of software engineers, probably way more than AI has. Um, but the reality is that just in a lot of things, as you improve your toolings and you become more efficient, you want more of that because it becomes cheaper, and then you can actually kind of scale it out. So, and then this is what has happened with software engineering the last few decades, with a lot of other sectors, right? I mean, there was these statistics about travel agents, and how that we now have more travel agents than we used to have before the internet, when everyone was going to the actual travel agency and buying the ticket. And I tend, yeah, I don't know. I mean, I just kind of, I saw actually kind of that statistics. I wouldn't be able to quote it, but I wouldn't be surprised because at the same time, yeah, I mean, like now you book a lot of the stuff online, but also like you travel way more. We travel way more where we used to. Travel is cheaper than it used to, and so like in a sense, you have like two different things that kind of work one counter another. So it's not like a clear cut. Well, of course, actually, you have less software engineers in the future. So it could be, but it could also be that maybe the job of software engineer kind of becomes different. And there are a lot of jobs, by the way, that have disappeared in the past. Again, kind of going back to the horses, probably there were like millions of people that were caring about the horses back in the day, and those people eventually kind of all kind of had to change their job as kind of mechanical cars. Maybe some people actually became mechanics of cars. Some other people went and do something else. I think actually, a lot of these things as technology improves, actually kind of society shifts and kind of will kind of create other opportunities for our endeavors. Um, Now, going back to software engineering, though, one thing I'll definitely say is that we are also kind of on the verge, on the cusp, if you want, of a big transformation. Because while until I would say probably last year or a couple of years ago, the code quality that was coming out of these bots was not good enough to completely kind of do things unsupervised by actual software engineers. Just to kind of paraphrase here, you would actually ask a bot to create some code, and at 95% of the times that code wouldn't work straight down. And you would need to be able to understand that code in order to fix it or to get the bot to help you fixing it. And now actually we're seeing more and more bots that are really performing a human grade on some of these tasks. Like more recently, kind of Gemini kind of perform on the web development um, um, benchmark better than most software developers. So we're starting to see these bots actually starting to create code at a quality that is comparable to humans. And I think actually, again, like what I was saying before, the problem shifts because let's say that, yes, okay, now you do have a bot that can create the code for what you want. But then can you actually still maintain that code? Can you actually evolve that code with a bot? Do you still need a software architect? Do you still need support? Do your support people need to understand the code they're supporting, or is just supported by bots? And so, again, I don't have necessarily the answer. I think no one has because this thing is moving so fast that is changing nowadays. But for example, as of today, yeah, a lot of those questions are still no's. And so, you still need a lot of people that do understand the code that is generated by a bot. And you still need a lot of people that are able to coordinate the generation of the code in a way that produces systems of code. Because that is usually not just a snippet of code that kind of solve the problem um, in a way that is functional. And so, all those things just to say that I think we're not yet at a point where we can kind of call that the work of software engineer not useful anymore. But definitely, we're going in that direction. I have no problem saying that. And by the way, like I mean, kind of the funny thing is that you said actually kind of it's funny about software engineers. One of the areas where we're using the most AI is actually to produce AI itself. We have a number of techniques that have come up over the years where AI helps, AI developers to build the next generation of AI. And, neural architecture search, we have a lot of like optimization. A lot of the code of AI is actually written by other AIs. So, has nothing just to do with software engineers. It even goes to kind of AI researchers themselves. Um, I'll just say one last thing, that is, again, I don't find this particularly different from what the even recent history of things has been. To me, the for maybe most striking similarity in terms of analogy, sorry, would be with the hardware development. Today would be absolutely unthinkable to build a modern microchip by just kind of human endeavor. You do need tools, and those tools are built with other hardware, and in a sense, like, there is a chain of technology that has been built in order for you to build the latest NVIDIA GPU or tensor units in a TPU from Google. You do need a lot of hardware to even get close to designing those things. And that hardware itself actually was not possible to be built by humans; has been built by other hardware before them. So it's like almost like a matryoshka set of dolls of like technologies that build other technology. And I think actually AI will it is not different at all.
Yeah, yeah. Uh, Man, so many interesting things, right? I would say, I mean, I'm, also playing devil's advocate, for the sake of, creating interesting discussion, right? But I would say this is one of those cases where we overestimate the short-term improvement and underestimate the long-term improvement, right? I think we're still a little bit far away from fully autonomous agents for software development. And I'm saying that, like, the other day I was trying to create some OAuth authorization flow, and I was like the most miserable, 5 hours,
Mhm.
just trying to, and this was using a language model, right? Like, this was using a state of the art language model. It was just like one issue after another, after another, after another, copying and pasting errors until, the model, between the two of us, we were able to solve it. And I was like, yeah, no, this is, it's still far away from, being able to implement, things on its own. Um, but I would say, you know, over the next few years, I think it's going to be very, very interesting as we see more and more of these areas, um, suitable for automation of some of these systems. So I think the example that I sometimes share with people, and I think a lot of people would agree, is marketing in many ways. So I like, you have language models that can generate images and generate emails and generate creatives, very, very well, right? And they don't need any correction. Right, like, I think a lot of that stuff is definitely going to be automated over the past few years, right? And I've seen a little bit of that, myself, right? But I imagined, at large scale, that would be even more obvious. Um, um, yeah, I mean, I don't know. I wonder if there are other areas where you see, yeah, these things are eventually going to be automated over the next few years.
Yeah, I do think, I mean, I would actually kind of argue that even in marketing, I mean, there is some progress to do, but absolutely, like, I mean, I think things like image generation, video generations are doing a ton of strides and are becoming actually, they're starting to become useful. Again, this is another area like software where, even 2, 3 years ago, I wouldn't have called that super useful yet. It was very interesting, but not very useful. Now it's becoming useful. I still see a lot of cases where you do need to iterate with the agents and the generative AI to get what exactly you want. And also, like, there are a lot of like aspects that very often like expert marketeers have to take into consideration that all of these models still don't completely kind of absorb. I'm sure actually, again, like, those are all things in evolution and they will get better and better as we speak. But in terms of other areas, so I think a very interesting one that is coming to life is more kind of embodied AI and kind of particular kind of robotics. Because again, that's another area where until recently it was still very, very prototypical. And you would see some examples of at least advanced AI applied to robotics, but they were more kind of gimmicks than real world application. I would say probably the vast majority of robotics out there, it's still run with very, very prescriptive, if you want, imperative programming kind of style, where kind of everything has to be very well sequenced. And now actually you start seeing kind of work again, kind of, for example, DeepMind has DeepMind Robotics. They have explored a lot of this world of how you get robots to learn the different actions that are available in an environment and the consequences of those actions, and then generalize to those and being able to put those in a right sequence without us having to spell step by step what to do. That is what we normally expect humans to do. So again, that's actually one area where, if you want, the intelligence of humans is still probably kind of way above the one of those bots, but where those bots are really kind of starting to kind of make ground. And I think actually that's extremely exciting in terms of the applications and the possibilities in the real world. Um,
Yeah.
Another, if you want, kind of aspects where things are still kind of coming along in terms of coming to age, it's kind of is more in the world of um, structured data processing. So kind of is a kind of an interesting story because, of course, AI started in the world of structured data when we used
Yeah.
to kind of just build this model just on top of structured data, and then actually there was this whole explosion of like, okay, now we can kind of understand also structured data, where it's kind of a structured text, an image, a sound file, or whatever. But now actually you're starting to see how you also want to apply some of these generalizability properties of these models also to structured data, or maybe to the hybrid of between structured and unstructured data. And so you start seeing a lot of application in that world as well. Again, the progress in this field is literally kind of in matter of weeks or months. So whatever data point you have today is only be valid for a short time. But right now, I still see that there are still a lot of advantages in having more kind of traditional data analysts kind of knowing what the data is and kind of being able to kind of extract the nuggets from it very quickly. Um, but actually, those AIs are kind of getting kind of very capable of also kind of doing something similar, and so that's actually also very exciting. Again, there are a number of like aspects where, yeah, the progress is not yet the level where, for example, kind of in conversational bots we've got, because keep in mind in the last 3 years, the vast majority of the focus has been on conversational bots and kind of honing those in as good as we can, because that's where a lot of people actually were interacting and where we're getting a lot of data.
That got really good. I mean, like, I think, yeah, I mean, in some ways, in my mind, like a state-of-the-art language model today, right, like can converse in a great way is maybe the application of those to like customer service sort of things that has been a little bit lagging. But some of these models can have really interesting, in-depth conversations about pretty much anything, right? That or even just chatting, right?
Yeah, so that's what I meant. Like, I wasn't necessarily meaning kind of application to customer service, but like if you go to ChatGPT or Gemini, hey, you can have a conversation about your favorite recipe for that pie, or actually learn about some kind of new concept in physics. And you will have very, very meaningful conversation. If you ask questions, you'll get very, very reasonable answers. I think actually those bots have become very good at doing those kind of things. What I'm saying is that this other new domains of applications are coming to age, because as we start applying these models, some of these other tasks, then we gather more and more data about them. And by the way, like agents, as in performing actions, is a big area where this is actually currently expanding very, very quickly.
Yep. I think for me personally, one of the most interesting examples is, last you mentioned Waymo, right?
Sure.
Because, there are, I think, 6, 7 million professional drivers in the US alone, right? So that is, if, once Waymo is, I guess, fully finished and rolled out and available, commercially and so on and so forth, that may have, very interesting implications, right, for society. Another one in the case of robotics is even just having robots that can navigate human environments and carry boxes of different sizes. There are thousands of people whose job is to unpack trucks and then, stock, shelves in supermarkets, right? And so on and so forth. So this whole notion of like navigating a human environment, and moving objects from one place to another, right? Like that is the entire job for many people, right? So I think that would also have very interesting implications. But let me go back to one of the things that you mentioned, this notion of a Tryoshka toll, right? Like, having,
Mhm.
a system built on top of another system on top of another system, right? I think, the same happens in biotech, right? And in drug discovery,
Mhm.
which is, I think, very interesting. A lot of people don't understand, right? Like, in order to develop a really complex, therapy, like a CAR T cell therapy for cancer or whatever, like there's so many technologies that are involved in that, right? And that's part of the reason why it's so expensive. Um, and so I think, the same metaphor applies there as well, right? I think, you know, in my mind, one of the interesting ideas is, well, if we have this technology that is really, really good, smart in many ways, or smarter than a human, right? But drastically cheaper, can we use that to develop other technologies, right? where there is a very significant cost, and the demand is essentially infinite, right? Like in so many other things in healthcare, right? But you know the usefulness of AI is not so much what can we do things that we couldn't before, but like can we do things um, that we need, many orders of magnitude cheaper, right? Because we just rely on these AI systems. And I think, that maybe one of the most interesting, ideas, right? Like, can we drive down the cost of all the things that we want, right? By using, AI smartly.
Yeah. Yeah. Yeah, and I would actually so let me bring like 2 points on that. So one is definitely kind of I think the democratization of some of those technologies and in a sense the intrinsic uh post-scarcity kind of aspects that they could create in certain areas of humankind. Again, like and hey, if you think about, for example, having doctors that could kind of just do a diagnosis from a smartphone. Now, I mean, that would not apply everywhere, but there are places where that is maybe kind of, life changing because you just don't have access to any doctor, like, I mean, let alone a smartphone one. And, kind of that kind of scalability allows a lot of improvement to our kind of, human condition. Uh, if you want a bit darker aspect of this whole Matryoshka concept is the danger, or if you want, kind of the concern around you losing the control on the technology. In that, so if you think about the example that I made before about hardware, right, and how hardware is made by other hardware is made by other hardware, and so on. What that sometimes causes, and you're seeing kind of, especially right now that there is more geopolitical turmoil, it can cause like isolated silos where some of those technologies become effectively either just the knowledge of a few that maybe kind of keep them private, or they even kind of get almost lost, right? And this has happened actually multiple times in the history of humanity, where kind of you build all those tools, but then in a sense, kind of the technology to rebuild them from scratch, if you had to, is lost, or at least become very, very hard. Um, and wonder actually kind of if eventually kind of we'll pass a point where like, okay, well now AI will build the new AI. Maybe that new AI will build the new, I don't know, life-changing kind of treatment. And by all those kind of steps, we as humans have maybe lost the understanding of what's kind of going on in this technology. Now, to be clear, like at an
And you
individual
will,
level,
the systems, right? Like that's a problem. It's just some crisis happens, right? Like, yep, how do you reboot from scratch?
right? Just to be clear, like I mean, this is already vastly happened at the individual level. Like no one of us knows how to, build remotely anything that surrounds us. But I think actually we're still at the level of our society where, like, if you were to kind of take the society as a whole, we do have the knowledge of almost every single piece of the technology that we use. And actually, the question becomes like, I mean, is this continuing to be at least from human society, or all of that actually will be delegated maybe to some of these more automated technologies? Um, I don't know, and I mean, I'm always like always optimistic around. We're very curious as humans. So, like, I personally, like, if I would know that an AI has found, actually, I don't know, like a new proof of a mathematical theorem, I would I'm assuming that there are a lot of humans, not just me, that would like to learn about that and how that works. So like I'm hopeful that we'll kind of keep up. But it's also true that there is also, and this actually is a concept that various philosophers kind of, and most recently kind of Elon Musk himself have brought out, that our intelligence in a sense is limited. Our brain is inside our cranium. It is what it is. And some of these artificial intelligence actually don't have that problem at all. Max Tegmark, by the way, has a lot of arguments about this in his Intelligence 3.0 kind of book.
Mhm.
And so, um, there may be a point where it just kind of it becomes above us, right? We just can't comprehend it. And that's actually what normally kind of goes under the concept of super intelligence. But again, I'm giving it more a connotation from a technological perspective. Like some of these technologies that are maybe built in the future via these automated means maybe in a sense kind of become too complicated for us to comprehend.
Yeah.
And I think actually that will be like a pretty kind of interesting point for our species to reach eventually.
Yeah. And I mean, we could continue talking about that for another hour, right? But maybe I'll just touch on. We'll leave that for another episode. But maybe we'll just touch on one of the examples. So I wish we had the capabilities, or I hope we will have the capabilities over the next few years to maybe use some of these super intelligent tools to actually
Mhm.
improve our biology, right? I think this is, a lot of people, for example, talking about Elon and his project of taking people to Mars, right? Like you cannot really spend 9 months in a space, going to Mars. With the current mechanisms that we have to prevent mutations, for example, in our DNA, right? Like, cosmic radiation and other things, I think will cause all sorts of issues, right? So one of the interesting ideas would be, well, can you improve, DNA replication fidelity in humans to prevent mutations, to prevent, basically everybody flying back and forth, to Mars to have cancer, right? We don't have the technology to do that. We don't understand anywhere near close, how we would actually design, like better, enzymes to replicate our DNA, to repair DNA, and so on and so forth, right? Um, I think it would be terrific if we could use some of this technology to say, well, let's pick up, our favorite super intelligent AI agent and say, design, better enzymes that prevent DNA mutations, and then design a gene therapy that get that into every single human cell, and then let's just use that to improve our own biology, right? And that would open up the door for us to travel into space, for example. It would open up the door for a lot of other things, right? Of course, I'm personally very, very interested in longevity, right? Like can we actually live much longer than we would otherwise would? But you could apply the same thing to say, well, can we improve our brain function? Right, like could
Mhm.
we design therapies that actually makes us smarter, right? So maybe we'll have a little bit more runway, even within our, biological substrate, right?
Absolutely. I think it's and I'm super excited to kind of. I think, in a sense, actually, we're already doing it. In that, you could argue that a lot of like medicines that we create today effectively help us living better in ways that we wouldn't be able to live. CRISPR and genetic engineering is already a thing, still kind of vastly under experimentation, but we already know that.
So I think the first CRISPR therapy was just approved, I think, this year, right?
Okay,
So and
yeah.
I think it's like, yeah, I mean, in theory, right? But yeah, in practice, maybe not yet.
One thing I think, kind of maybe before CRISPR, people would have had like concerns around, is this even feasible? Right? I think actually now we know a mechanism that in theory should work to do certain kind of whole body genetic modification. Because I'm talking about, of course, like, we knew already before CRISPR how to modify an embryo and maybe do something with it. But like the idea of like taking my body already grown up as an adult and kind of being able to change some of my genetics, it's something that really kind of became even feasible, after CRISPR, I think, at least. I'm not a biologist, but
Yeah, yeah. I think that's all link thinkers, and there were other mechanisms before too, right? Like, so I would, yeah, I mean, like, I would maybe qualify that, but I'm not a biologist either, right? So, maybe next time I have a biologist on the show, we'll
yeah,
do that.
but maybe like instead of like being 15 years, maybe we're talking about 25 years or 30 years. I mean, I'm pretty sure that if you go back maybe kind of to the 60s, people were not necessarily kind of thinking about changing DNA in every single cell at the same time. But my point here is that I think these things are feasible in that actually we know they're physically possible. That now we don't know if they're safe, if we can make them work, if they work as we want, and all that kind of good stuff. But we know that it is possible. And actually, that's a huge step. Um, I think, like in terms of intelligence specifically, so talking to that, of course, like you can imagine kind of boosting, if you want, our um, neural system in ways that make us more intelligent or, more able to do certain things more quick or whatever. And the other direction where people are going right now, and that's kind of where some of the folks like Elon Musk actually kind of has been going is like, can you actually interface the brain to machines to kind of expand you in kind of hardware that is not necessarily biological? And again, I mean, there are a lot of like ethical and, even physical and medical problems with that. Uh, but I think definitely kind of this idea of augmenting us as a species is out there. The thing I think that a lot of people go to though is that like kind of going to your kind of example of like going to Mars is from a rational perspective, why would you even do that? Right? In a sense, like, why don't you just send like a robot there and have it, kind of do things on your behalf?
Sure, because we want to read there in person.
Absolutely. Well, I mean, I understand that. But again, like if you think it from just a purely rational perspective, you would actually,
Yeah, right? Like you want to know Russian.
absolutely, absolutely. So but the point I'm making is that there is also like this counter tendency of like, okay, well, I mean, kind of are us as biological being becoming kind of limited to the point that maybe, kind of for certain tasks actually will use something different. And I think again, like, I mean, this is something that again, it's not new. Like we've done it many times. I mean, I wouldn't go in apnea, uh, you know, 3,000 feet under the ocean to kind of find the Titanic. Most things actually kind of would go actually kind of not even with a manned submarine. You basically use a drone because a manned submarine can be too dangerous. So, and we are completely used to that idea. So, like, we have rovers on Mars today, and they're doing a great job. They're exploring the planet and collecting a lot of data. Um, whether we necessarily want to go there in person, yes, it's very exciting, but you also have to kind of, compensate that with like the technical difficulties. You mentioned a bunch. I would also mention the fact that there's no oxygen over there. And like you'll have to kind of find a way to create basically kind of sustaining life systems. And that's actually extremely complicated. Like forget about the radiation actually going there. How do you get humans to survive there for months? Because that would be the minimum time. I mean, again, a lot of folks are working on that. It's not unsurmountable. It's just that it's very, very hard. And so in a sense, kind of that's definitely kind of going to be part of the discussion. But
Yeah. We touched on so many things. I have to, rewatch the whole podcast, yeah, afterwards, write down all these things and then use it as a starting list of questions for the next one. But maybe just, a couple more minutes to finish, right? Like, what are you excited about, any of this, technology, any application or any new kind of, fundamental idea that it's popping up, right? Like, what gets you um interested or excited, or is it something that maybe we haven't talked about yet?
in I'm going to talk actually kind of in the world of AI because that actually is the part that I know the best. So kind of I'll constrain to that. So and because actually we've interacted on that actually kind of in the past, but like one of the biggest passions still of mine is the idea of reinforcement learning. That is how we learn things by basically interacting with the outside environment. And the reason I think actually this is even more exciting today in the world of large language model than it used to be, let's say, 10 years ago when we're applying to things like the game of Go or, kind of playing video games, is that again, like now we have a much better way of building agents and systems that have analytical, deductive, and inference capabilities. And we're getting, in fact, we already got to a large extent to points where the amount of training examples that we can provide these bots about the things that we want them to do is becoming the scarcity point. In fact, one of the things that makes reinforcement learning fascinating for me is that reinforcement learning is that learning techniques is basically the one that we know of that allows us to train things that actually are better than us. In a sense, like in a lot of normal kind of deep learning, machine learning, you train with supervised example to show a particular model what is the right solution to a problem. Now, one thing that this implies is that you have to be able to know what the right solution is for a particular problem. And that is kind of exciting and extremely useful in a lot of like domains where we humans are very good at doing a particular task. My main example is if you have to recognize a cat or a dog in a picture, we're good at that. We're not perfect, but we're very, very good. And so we can provide a lot of examples of that. But if you want to train a bot to become the best player at Go, well, I mean, like you can only get as good as the world champion of Go. You cannot kind of provide example better than that. If you want to go beyond that level, now you have to come up with something different. And that's something different has been for, at this point, many years, reinforcement learning. And actually kind of very recently, we've had like a number of applications, particularly kind of, for example, DeepSeek made a lot of news, but like DeepMind and, kind of OpenAI and Anthropic have all been using reinforcement learning to improve the capabilities of their agents, um, and and this is becoming kind of is really becoming an extremely valuable tool to have these agents effectively kind of learn things beyond what we can provide as examples. So that's definitely kind of one thing I'm super excited. And again, it's also one thing where I'm expecting probably like big leapfrog steps in the next few years in terms of kind of that's where I would actually imagine actually a lot of the improvement will come.
Yep, yep. And I would imagine it would be even more interesting for areas where we as humans find trouble intuitively grasping things, right? Like, so if you think in terms of like designing new materials and engineering, right? Like, we don't have an understanding of like, crystallography at an intuitive level, right? Like, so like even an expert human would probably have a lot of trouble designing some kind of, smart material, right? Or whatever, right? Or I mean, certainly in drug discovery, they were like, we, humans, maybe not me, right? But like, even chemists and drug hunters are like, have trouble designing molecules that could be drugs, right? Like, we just don't have an understanding of like quantum chemistry at that intuitive level, right? So like maybe reinforcement learning would be actually interesting. And this is a great idea because I don't think anybody is doing things this way yet.
Yeah, yeah. I mean, so in a sense, kind of an example of this, you already seen it like with AlphaFold, where like in a sense, kind of the intuitions that we have about certain things easily breaks down at those scales and complexities. Again, I made the example of Go as a game, just kind of it's a complex game where things actually have gone. Like I would actually argue, one thing that is very fascinating, for example, kind of about materials or chemistry or biology, is that very often, the way in which we work as humans in terms of our intelligence is that we work by analogies. We basically try to use a problem that maybe was simpler and that was solved to basically understand better on other problems. And those analogies are extremely useful, right? In physics, we used to say same equation, same solutions, and has been actually a guiding principle of a lot of physics. In fact, a lot of folks actually say that all of physics is based on the harmonic oscillator, and that is truth to that. But the problem is, very often we human have again a certain kind of limited capacity of making these analogies, especially from very disparate field. That's why you've seen actually a lot of the challenges have come from what are called kind of the mesoscales problems. I mean, whether it's kind of complex chemistry where you're going kind of very very large molecules, or like complex biology where you have a lot of like components. Those are usually the things where we've been struggling because at those scales you have to keep a lot of things in mind. You have to be able to kind of draw analogies between very different domains where maybe you've been trained as a chemist and now you have to kind of draw analogies into, I don't know, quantum field theory. And actually, in a sense, AIs may be much, much better at doing those kind of things because they have, of course, much better capacity of like holding all those concepts simultaneously.
Yeah, that's super interesting. Yeah, I mean, in my mind, right, like the example that comes to mind, very, very obvious, is cell biology, right? And we humans, think in terms of like, molecules interacting with each other in pairways or pathways, right? But like a cell is like a city full of people, right? Interacting in many different ways, right? And an AI model can keep all the stuff in mind, in a way that a human could never, would be
Mhm.
able to.
Yeah, I mean, like this happens, like, kind of the difference between the different scales of our world is it's massive. And like, there are people that understand quantum chromodynamics, they understand how the nucleus of a particular atom works, but they don't understand how the atom outside actually kind of works. That actually drives chemistry because they just specialize in that. And like you have all these kind of scales between different things. That's where a lot of like the complexities are. My best example of that, is, for example, is weather prediction, where like we understand very well the laws of physics at that level between the different kind of molecules and how actually kind of temperature moves. And but like the idea of like predicting these large systems becomes very very complicated when you start kind of having them at that scale. And actually we're seeing kind of recently a lot of strides actually with applying AI to that. I mean, Google would build this model GraphCast is exactly able to kind of build those kind of between scales kind of patterns and understand better knowing the physics, but at the same time understanding the pattern between the scales in a way that allows to predict much better what happens.
Yeah.
And I think with that, we'll have to leave it here because otherwise we will go on for another hour. But and this was a fantastic, super interesting conversation. Thank you so much, Masi. It was, as usual, a pleasure speaking with you today. So, thank you for everything. And then I'm going to write down all these things, so that we'll have to do a second episode.
And love to. Happy to chat anytime. And these are all kind of super interesting topics that I think actually, honestly, like more and more people should think about seriously. In the society, I think it's going to be important. Yes. Thanks a lot for having me.